Okay, time for our last session. We have a panel that came out of a paper submission. The panel is going to be chaired by Leslie Daigle, who has been around at the IRTF since 1995, so for a substantial amount of time. So she has seen all kinds of ups and downs and changes in the internet, and that's probably puts her into a perfect position to talk about internet health.
Thank you very much, Jörg. So yes, this panel came out of a paper that I had submitted for this workshop about the network operator measurements activity that I've been working on. You can find more information about that at www.techarc.org/NOMA, or more likely, talk to me afterwards. So we're not actually going to talk about that, although I will provide a bit of context from it. But instead, we've got panelists here who are very well positioned to talk about metrics and internet health. I will ask them later to give a more detailed introduction themselves. But first, I would like to thank John Verzasca from Comcast, Victor Korsing from Oracle now, and Robert Kistelecki from RIPE NCC for agreeing to be on the panel. So, so the basic thesis behind the NOMA work is to get operators, network operators, to self-instrument, to take measurements from the edge of their networks towards some well-known, user-interesting resources in the center of the network, to get a sense of how well their network is working. Let's put it that way, really roughly. The measurements are not complex. Things like measuring the time for HTTP connects over v4 and v6. And the thesis is that maybe a metric like doing the ratio of v4 and v6, or the difference between v4 and v6 times, would give you some sense of which protocol is working best from the vantage point of where you're testing. And if you look at it over time, you can have some sense of whether v6 is getting better or worse or what. So that is an extraordinarily high-level thumbnail sketch of what I was talking about, just to sort of lay some groundwork for the background that I was coming from. So I did actually have a panel description. Instrumenting networks, measurements to track network and internet health. This panel will explore the challenges of establishing a measurement collection framework within an operational network, instrumenting it for the purpose of tracking the network state, as well as contributing to a picture of the overall internet state of health. Apart from narrowing down what internet health actually means, challenges include choosing measurements that are meaningful markers of user experience, carrying out measurements within the network without otherwise impacting the network's performance or perturbing any target resources at which measurement traffic is aimed. No DDoSing. And these and other challenges and insights will be discussed by the panelists, from operators to infrastructure operators and network architects. So that's the context of this panel. And at this point, I would like to turn to the panel and ask each person to give a brief introduction of themselves, their background, and their relationship to this particular topic.
Okay, going from left to right, apparently. So hi, I'm Robert. I have been with the RIPE NCC for 11 years now, coming from security background, network security in particular. And then I joined the NCC to do RPKI, which some of you might have heard of, protocol work and so on. And later on, joined the then forming science team, which is now the R&D team. And I'm managing the R&D team ever since then. So the involvement here is that the NCC has been very active in the measurements and active and passive measurements of the internet for some time now. Some of you know RIS, the routing information system that has been collecting BGP data from around 700 peers or so since 1999. TTM, the test traffic measurements. Oh, public data is available, so that's kind of goes without saying. The test traffic measurements, which were instrumented, rack-mounted boxes with GPS antennas mounted on roofs and so on, so they can do one-way delay measurements with high precision. That was also running for like 12 years or so. Now it has been superseded. So we've been in this space for some time now, and somewhere around 2008-ish, we came to realize that there is, if network operators, which is our primary concern because we try to serve the ISPs in this region, whenever they have questions about, I think there is something wrong with the internet, it's not me. I don't really know who causes the problem and if there is a problem, but I feel that something is going on. There is a disturbance in the force, or someone actually complains about it. How do I go about it? How can I figure out what the problem is, where the problem is, and who is to blame, or how, more importantly, how can we fix it? So the only way was to talk to your friends and say, I think you have a machine in Vienna, right? Can I start pinging from there? And then rally up those kind of people to support you. So the intuition was that we still need some kind of measurement network that people can play with, and it gives them enough eyes or vantage points all over the world so that they can debug these kind of problems. Now, the RIPE-NCC is trying to stay on the network level, so our primary concern is the health of the network and not necessarily the health of applications and various research type of weirdly shaped packets and so on. But those happen as well. So we are trying to stay on the ping traceroute DNS and so NTP level. We do have HTTP measurements as well, but they are not publicly available because of reasons that we can go into later if that's a topic. But our approach was to build basically a community-based network. So if someone is willing to extend the network, then we should let them and we should encourage them. But in return, they should get some benefits out of the network. And I'm assuming that most of you know what RIPE Atlas is about, that's basically what you get. If you run a probe, you can do measurements. There's this loose correlation between the two. And along this road, we saw that there is a huge need for easily accessible tools and visualizations that monitor the health, if you will, whatever that means. You can also talk about that. But people, at least our target audience, were people who didn't really want to spend the time on figuring out how to do a measurement and then how to interpret the results. What they want is, does it work or doesn't it? And if it doesn't, who do I talk to? And I have to say that's surprisingly difficult to achieve.
All right. So my name is Victor Coursing. I'll give you a bit of my background and then I'll share some opinions. Currently working, I'll go backwards, I guess at Oracle, as you mentioned. We just got acquired. Our company was Dyn. So we're very much on the cloud services side of the equation at this point. Prior to that, small stint at Cisco, and then before that, about 13 years in a service provider up in Canada. So doing wireless and cable operations and business operations. So I've seen the issue from multiple perspectives, and that includes seeing it from the content/service provider, cloud provider side of it. You're trying to offer what is an increasingly common phenomenon of a third-party network offering services into SP networks, and that dynamic of where does the service issues lie. Seeing it from a vendor perspective as how to tool our equipment correctly so that SPs can leverage or turn on the right functions to be able to metric their network or take statistics out of it and figure out what's going on. And from the SP side of the house, which was, if I think back to the late 90s and early 2000s when we did this, a lot of the functions that we require to understand the health is our networks were quite segmented back then. We inherently had that. It was part and parcel of that vertical integration we had way back then. And what's happened is, as we've kind of made this more ubiquitous network and data centers, and things have become more common on a single fabric, what's the issue we have is we haven't replaced all of those functionalities with a common set of tools and metrics to be able to understand how does our service now run now? How do we deal with an infrastructure that has many services on it? And how do we understand, I know you want to get to the applications later, but how are we going to understand, or what's the right type of data to get out of here to understand what the implications will be for the upstream applications? So that's kind of my interest area, spending a lot of time, in terms of architecture, design, and operating all these systems from these different perspectives. And I see it as an increasing challenge because I see that not only inside the SP, are their applications or their services moving to these common data centers, and how do they figure out what's actually happening within the network? Because we struggled with that. You know, if we go back even starting about 5-6 years ago, we struggled with how do we convert all of these, what used to be these inherent tools we got from the vendors, to what do we create to be able to understand that, and a lot of the things happening with the internet. And then from the service provider's perspective, I mean, the content provider perspective, or, you know, the upstream cloud provider's perspective, is how do we access tools, or how do we provide functionality cooperatively with the SPs so we understand the health, so we don't get this finger pointing, or we don't, you know, where does the problem lie? Is it in the access network? Is it in these increasingly complex backbone networks? Or is it in the interconnection layer between all the providers? Or is it inside the cloud provider's infrastructure? And how do we tool these to get meaning out of them in a common way, so we could, at the end of the day, fix problems and really understand the health and attributes of applications. So that's my first synopsis.
Thanks, Victor. My name is John Verzasca from Comcast. Been with the company for a long time, going on 12 years now. So you know, anybody who knows me here, the vast majority of what I've done over the past decade and change is I've led the company's efforts to adopt V6. So about you know, probably the best way to describe this is the, you know, first few years of the company were a lot of, you know, thankless work to upgrade the infrastructure, ready the infrastructure that actually had no visible benefits or movement from the public's point of view. Upgrading servers, operating systems, products, what have you. So about 6 years ago, is when we started to really launch things that were going to end up in our customers' homes. Around that same time, when we were getting ready to do that, you know, we talked to, got all the right approvals internally, and one of the kind of the requests, air quotes, was don't break anything. Got it. Don't break anything. Right. So that ended up kind of blossoming into what ended up being an opportunity for us to kind of measure ourselves. Right. Initially, it was from a binary point of view to make sure that we didn't break anything. Right. To follow our, the kind of the mandate from our leaders. Turns out over the years, we ended up building extraordinary relationships with many other partners in the ecosystem, which we'll talk about here in a few minutes. But it's also really kind of taking us down a couple of paths, right? It's, when we deployed V6 as part of kind of enabling it on our infrastructure, we did it in a way that we didn't just simply carry forward the things that were done before. We looked at different, V6 is an opportunity to do things differently, better, optimize, right? So if there's things and baggage that was happening that was in place for V4, we wanted to take that as an opportunity to perhaps not do that again from a V6 point of view. That in turn led to a series of interesting phases where we said, hey, well, let's just take this from not a binary approach to measuring, are we broken or not, to, hey, wait a minute, what's the difference between V4 and V6? Oh, and by the way, in many cases, V6 outperforms V4. What are those scenarios? What can we explore there? And then finally, I think the chapter that is about to be upon us, and maybe in some places it is upon us, is what happens when V4 starts to degrade, right? You can't go back and measure, right? You can't go back in time, right? So, starting these measurements and letting them run for extended periods of time is critical, right? And at least having that foundational baseline data is essential. You just can never go back in time to re-get it, right? So T0, you can't go back to, right? So with that, Leslie, I'll turn it over to you, but that's the fundamental premise around why I think, I'm up here, right?
Great, thanks. So I sent you all some questions that we get to, and let me now start with one that wasn't among those questions. But just sort of to put a little bit of a finer point on it, at least two of you brought up the notion of, doing measurements can help you see where there are actually problems in the network. I wonder if one or more of you would like to give a concrete example to the room of where simple measurements can let you see something that's fundamental and important in the state of the network.
I have two. One that it dates back to World V6 launch. Was that 2012, right? Yeah. And one that's happening right now, right? So when a good friend of mine, Paul Saab at Facebook, right? So I was visiting Paul in his office, and at the time, I guess it was Palo Alto, and he's like, "Hey," so it's a month before the event. He goes, "Hey, let's let's turn V6 on and Comcast network. I said, okay, let's
Just
do it.
hanging around saying, hey, yeah, why don't we turn on V6?
I said,
Cool.
let's refill the beer first and let's give it a go. Let's give it a go, right? So and I said, hold on a second. I said, let me plug in www.facebook.com into kind of like the system, right? We'll talk about what the system is later. And he turns it on. We go out, get a bite to eat, come back, and I said, dude, you might want to turn that off. So it turns out in that case, and this is exactly the kind of relationship that I'm describing that blossomed, that really helps the internet ecosystem get together and fix things that affect millions of people on the internet. Turns out, the V4 traffic was being served out of something relatively close to Chicago. And then Chicago, but V6 was being served someplace in like the northwest of the country. So I'm like, it's not horrible, it's not broken, but it's not, the best. So we turned it off, he went off and did some things. A day or two goes by, we turn it back on, looks good, right? So that was really more of like, is it broken or not, right? And then lately, we have a situation with a content owner and a CDN where I happen to be measuring, so these relationships have kind of continued to blossom. The CDN, the content owner is basically LinkedIn, right? And I get a bunch of requests from them that says, hey, what's it look like on your network? How's things going? Because we're getting some reports of some issues, issues, right? So you plug in, LinkedIn URL and then collect some data for a while. And what we're finding is that there are issues both on my side and on another third party side where it's potentially affecting kind of the customer experience. Again, not broken, but like again opportunities for optimization, right? And the measurements, Leslie, and if you want to get into this later, that'd be great. They're not sophisticated. It's basically a wrapper built around libcurl, right? That basically does DNS lookup, TCP connect, and download time. Very simple for V4, V6.
Which you have distributed through your network.
Yeah, that's correct. That's right. Not entirely, but enough.
Anybody else? Yeah, I'm going to switch microphones on you because I think this one's easier for you to pass.
Grab two examples. One will actually reiterate something that John just said, and then I'll jump into a second one from a different perspective. So to the same event, different network, IPv6 Day 2012. When we were ramping up to it, we saw a very similar issue. And on the DNS, to go into the details of what we found on our SP side network was that, one can argue this came down to design deltas. This will continue to be true between V4 and V6. The V6 network was built differently because it was supposed to be built better. Why do we have to go back to the V4 world? Let's not make this necessarily 100% congruent. And what we found was, traffic was just inherently routed differently. Policy points in the network, how we did BGP policy across the network, and how we advertise things, although it was supposed to be the same basic general Anycast DNS distribution inside the network, wound up taking traffic to different data centers. And when we worked backwards through the problem and found out where the issues were, and by the way, we found the issues because it was painstakingly like trial and error. What's going on here? Why is this happening? It wasn't instrumented. We discovered, there was issues within the network in terms of how the config was done, and we found out was a lot of manual processes on the V6 side. It was quite new back then. So, that's just to reiterate one of the things that John said, that we found that. So it's more than one network had the same or similar kinds of issues. We ramped up there, and it was one of those, wow, this can actually happen. And we've had other examples. Another perspective is I find implementations are differed between vendors. I'm not going to give away any vendor equipment at this point. But one of the things we found more recently was we had an issue where V4 actually kind of sucked. And we didn't have a V6 problem with this specific traffic flow when we were figuring out, what's going on with our UDP traffic. It looks like it's being dropped on the floor, going into this data center, what's happening. Well, we realized, now this might be that maybe the V6 implementation of ALGs was broken, but it sure performed very differently between V4 and V6. So we got a totally fundamental different behavior between V4 and V6 in terms of how UDP traffic was being managed. And there was some asynchronous nature going on without going to the big details. Now, had we been able to instrument the network, we could have found this problem a lot sooner than, and by the way, SPs will buy the exact same equipment we were using in these specific instances. We could have found this problem a lot sooner and not waited for, incredible number of tickets, a lot of problems, a lot of issues, a lot of troubleshooting, a lot of man hours. And, I'd rather spend that, to be honest with you, doing actual network implementation work as opposed to just troubleshooting. So it took a long time to find this. So we're seeing just implementation issues are hard to find. So instrumenting things can help us find things. In this particular case, V4 actually sucked more than V6.
I am constantly surprised about how much value researchers can squeeze out from the same data set day to day. And it's just a thing that we are still using the tools that we've been using 40 years ago, literally. Ping, traceroute, DNS lookup. And the volume has changed a lot. And I think in terms of detecting problems with V4, with V6, which one's better, what has changed, having a significant amount of constant data inflow helps a lot. We are measuring something like 4,500 results a second. That's what we collect, so 400 million data points a day, which is more than enough to pinpoint problems when they occur. The trick is, or one of the tricks is that it's nice to collect baseline there. So, referring back to previous examples, if you knew how the network behaved before the problem came, and now you measure how it is behaving, then you can compare and say, that's the problem right there. Once you have a problem and then you start to measure, it's a bit more difficult. But it helped a couple of times when my colleagues developed tools that just took significant amounts of data and just merged them all together and say, this one is the outlier, that one is the outlier. We built like traceroute tools where an operator can say, show me how the world sees my website, or can trace to me on V4 and on V6, and then it visualize that. And suddenly when you see, instead of a tree, if all those sources come to you, you see a forest, that these guys get to you and those are blocked. That helps a lot. And then you can compare what is the difference between V4 and V6 here. And that's just one simple tool, and you can extract a lot of value from it.
Okay, so I want to hold on to this thought of the sort of the simple tools, the 40-year-old tools for measuring internet infrastructure and the value that you can get from it. I'd like to switch gears just a little bit to another question that we had discussed in email before, which is a lot of what matters, at least for access providers, is how are the users perceiving the network, their use of the network. And they don't particularly touch the network itself, the network infrastructure. So how can you make the leap from what you can measure within network infrastructure to getting some sense of how is this working for the users?
I think that's really hard, especially if you look at the fact that the technology that the end users interact with changes so quickly, even. So it's really difficult to have measurement points inside your network or inside your customer's network that try to simulate what the users will see. Basically, you have to re-implement the happy eyeballs as those guys did it over there. But if your population happens to prefer a different browser, then their experience will be different. So in that sense, the only real user-specific metric, like how do the users feel about this change, would be the actual end client that the user is using. And that's kind of difficult to get to and limited. People try that, and some plugins still work. But I do feel that on the network level, we can do a lot of measurements and a lot of guesswork. And some of that guesswork is pretty accurate, but it is never going to be the same that the user experiences. So it might be a personal opinion, but I think that's difficult.
John wants to.
Yeah, so it's fascinating. So even the way that we've done some of the measurements that we've been doing for a while now, we can kind of initiate many of these, and that's frankly why we chose HTTP, right? Because HTTP vertically, when you include all the protocols that go into kind of an HTTP exchange, it's like it's a pretty good place to start. I mean, is it perfect? Is it all encompassing? No, but it's got a very long runway of things to factor in. I mean, there's plenty of work that can be done just on that vertical space alone. And what we've also noticed in our network, ours is a pretty big nationwide network. So we have these regions, Boston, Philadelphia, Atlanta, Chicago, Denver, San Jose, San Francisco. We have probes that are kind of generally in each of those regions, right? But one of the things that we think that could, really help to augment that is kind of pushing it closer to where the customer resides topologically in a network, right? And to Robert's point, even then, it's not exactly perfect, but I mean, it still represents a kind of cornucopia of data opportunities to really analyze and evaluate what that experience looks like. Ultimately, after the day is done, it's really something like this, right? That I think to Robert's point, you have to factor in what the kind of the visual experience is, what kind of computer does the user have, et cetera. But absent that, there's still tons of opportunity to really evaluate what the potential impact to customer experience.
So, it's not working so well. To try to tie it into some of the stuff that was discussed earlier in today, I think that what you're saying is it's probably pretty hard to get the fine-grained tracking of user experience at the level of trying to see why or where there are hiccups, for instance, in a particular audiovisual stream. But at the level of detecting when you've got a DNS server that is not doing the right geolocation and is sending a Boston customer to the San Francisco instance of something, I mean, I think you can measure user experience at that level.
That was exactly the issue that we had with LinkedIn recently, right? Somehow, the Anycast DNS servers that we send to the customers, the cluster in a particular region was not enabling the proper geo, and people in a certain part of the country were going completely somewhere else. So that could be a byproduct of routing policy on the Comcast network, something with the DNS infrastructure. It could have been a byproduct of their CDN provider not having a right geolocation map for the Comcast network, right?
Go ahead. Victor, you want to say something?
Yeah, I felt like I wanted to say something. And this was kind of aligns, and this was more like I raised a question when we were talking about this in the background. Thinking back to that content, imagine you were watching some kind of streaming content from a very popular provider at home. One of the things that I grappled with is how do we understand what the quality is that you. Yeah, I understand the infrastructure side. We understand what we need to instrument to kind of get a coarse view of how the infrastructure is actually working. So, John and I could be in our relative homes. We could both be in Philadelphia. Imagine I moved there. And if we're both watching this content, suddenly for some reason there's a red drop somewhere in the network. He drops down in bandwidth for his stream, so he's no longer getting his 4K or HD signal on that stream. But I was fine. I didn't get that random red drop on a router somewhere in the middle of the network. And so the question is, was the internet good at that moment in time? It wasn't a peering problem likely. It may or may not have been something on the IX exchange. Probably not an issue on the content side. Maybe somewhere in the middle of his network. Maybe it was on the access network where that happened. But the question I have is, is that good? Does that mean that there was a problem in the network? Probably at macro scale, there really was no issues there. But his experience was that there was an issue. He no longer saw his high definition video come through on a streaming service. So that's where I try to figure out how we're going to get the correlation between the user experience and is there a way to do that with infrastructure data. Back in the old days, not that old, 15 years ago, video was totally different in an SP network. I mean, we instrumented right down between set-top boxes and where the video was feeding in is the old MPEG feeds. So we understood artifacts. We understood macro blocking very, very well. There was a high correlation between what you saw on the TV and all the instrumentation happened in this vertical stack and what we got. So we knew what was happening. But now in this more ubiquitous space, it's really hard, in my mind, to kind of create that connection. And we, how to recreate what we used to have.
All right, I'm going to stop pressing that button. I had to do it once more to get it turned back on. I have a question I want to follow up, but Randy, you look like you're being patient.
2 words, 1,000 eyes. Our biggest customers use 1,000 eyes.
Okay.
And they very thoroughly answer the question you're asking.
Sounds like some homework. Where I was going to go, and I will go since I'm not going to Google that right this minute. It kind of sounds like what's being described here is that from the perspective we're talking about today, it's not really particularly possible to simulate or measure the exact user experience because of all the reasons that you raised, Robert, for instance. But we might be able to start getting to the question of how well is the network, for some value of the network, serving end customers. Although, Victor, you were suggesting that in our multifaceted world today, even that's pretty hard to come up with a baseline. What should the network be doing in order to serve people well?
Yeah, and just to add to that, I mean, interesting what Randy mentioned there. Maybe some homework to be done, but the thing is, all the networks are not also created equal, right? So they're all designed to some different level of function. So the way Comcast might design their network is fundamentally different than the way we designed our cable network that we had. Our networks look nothing alike. So, so the question is, we might get different user experience, but the other thing too is maybe they were both good in each one of our own eyes.
All right, so as we're sliding down the hill towards a sense of despair and a morass of negativity, so how about the health of the internet? Is there any way in which we can, I'm going to be positive, we can talk about health metrics, not from the standpoint of being able to answer all questions, but at least from the standpoint, as John was articulating it, creating baselines. Let's make this T0 and start measuring some things, some pretty basic things, so that when we subjectively decide that things are not working well in the internet, we can turn to some objective metrics and say, this is what has changed, or this is what is different in this network versus that network over there. And if we were going to do that sort of thing, what might be some of those things that we could measure and find useful?
So do I have to pretend like today's T0?
As you like.
How about I'll share a few things that we're looking at lately, right? So one of the things that we're looking at, is the DNS, right? So one of the things that we found is, and I was talking to a lot of the ISC guys over the past several ITFs. We said, hey, we think there's something up with kind of DNS, the DNS in general on the air quotes capital I internet. We're like, it seems to be, and this was a few years ago, it seems to be like just, grossly biased towards IPv4. No, that can't be the case. We're like, yeah, we think it is. So we did some digging. Obviously, if you don't have a good path to, recursion over v6, then, the DNS will do the right thing. It'll use v4. Turns out there's a lot more than that. Even internally on our network, our recursive name servers were not, there was a bug, plus it was not configured as such to prefer recursion over v6 first. The way, I think Robert described happy eyeballs, maybe it was Victor. So we ran some tests and we found out that, recursion, DNS recursion over v6 was actually faster than IPv4. There's about 10 cases on the Comcast network to Asian authoritative DNS servers that were pretty bad. But, I could pick up the phone, make a few phone calls to say, hey, something at .in or something and .over, whatever, you got to fix this thing up, right? But the vast majority of it was like v6 was outperforming v4, right? So that was one of the scenarios where we had, the measurements that we started at T0 6 years ago that actually sprungboard into other opportunities to basically improve the customer experience and the performance of the internet.
So you're saying that even doing just sort of basic baseline measurements about timings for doing DNS lookups towards popular websites, looking at things like overall time to load for page requests and whatnot, provides some level of building blocks for addressing questions.
You didn't even need to do the page load necessarily. You can just do the DNS query.
Right.
Have a DNS cluster out there that only has a v6 interfaces and just do the DNS queries and figure out, load up the Alexa top, whatever, right? I think that's what we ended up doing, and see what the DNS lookup times were. Right?
Yeah, not the Alexa top. It's what now? The Cisco top million now? Go ahead.
So just to kind of jump on one of the things that you were saying, I think DNS, now I have to remember there's some bias here at this point because I happen to be working for a company that makes money serving with DNS. So trying not to take off the bias hat, try and take off the bias hat, not have a bias, is I think that's a really good space because it's a fundamental part of the experience of a lot of usage of the internet, right? Assuming you're not off in the dark web somewhere. So it's a fundamental part of that experience, right? A lot of what the customer will see has to do with DNS performance, and it also, to make that work right, a lot of infrastructural things have to be right or wrong. Now we get escalated on quite a bit because if you're hosting some big name brands, what happens is you get a quick aggregate of problems and you notice it pretty fast. And we've had to troubleshoot with other providers, anomalies in their V4 and V6 routing. A lot in the V6 routing space. You'd be amazed at how V4 and V6 perform fundamentally different in terms of how people happen to route that across their networks. And so, as we had to fix a lot of infrastructure things that seem to have nothing to do with DNS. Like your BGP, you say no export, you do an export, or fundamental things you think should be working don't work, and so we worked down. We wound up fixing just basic routing issues in other people's or our network, and obviously it goes up and fixes the DNS space. So I think measuring that has a lot of flow through benefits as well. So I would agree with John.
We saw so much of that, even recently.
Okay, so I'm going to open up the floor to questions from the audience. And while you're organizing yourselves towards the mic, I'll throw out one question to you, Robert, with the Atlas infrastructure or the measurements infrastructure in general. Have you noticed differences over the last few years, shall we say, of who is using the infrastructure and how they're using it, what kinds of questions they seem to be trying to answer? Or is that not something that you can get any insight into?
There is, interestingly enough, a research paper published by Randy and his friends looking at who is actually using RIPE Atlas. So I think that the title was Measuring the Measurers or so. So who are using RIPE Atlas and why, and what kind of behavior they show. And they identified, I'm not authoritative to talk about the paper, but they identified two classes of people. One who really know what they are measuring. So they have a specific problem, and now they're shooting out a bunch of measurement requests and then trying to parse the results and figuring out what's going on. And then the other class of people is, I'm trying to stay away from their terminology. The other class of people were the people who just did measurements all over. Like, give me everything, measure everything, and I want to download it all, and then figure out what I actually want to figure out. So those still exist. Our original goal was to address operators because we thought that they need this tool, and I'm very happy to report that like 2 or 3 years after we started, and we had to push a bit at the beginning, but 2 or 3 years after, we started seeing talks appearing from operators at various conferences that said, oh, I actually had a problem and I used Atlas for this, and I used Atlas for that. Nowadays, if you go to a RIPE meeting or virtually any other RIR meetings, and even here, there is a talk at every session or every day at the minimum saying, hey, by the way, we use this, which is really nice. Besides this, I did see a huge take-up in researchers using Atlas, and I'm very proud of that. And it's just one thing that researchers will try to get their hands on anything they can when they think that there is value to be extracted there. But I think there is more and more and more conscious usage of Atlas because there are specific questions that the researchers feel that this platform may not be the best, but at least it's there, it's usable, and it can provide insight. And that's useful for the operator community as well in the end, especially if the outcome of the research is something tangible where people can just say, I understand what you did, and I understand how can I apply that to my own network. That's highly useful.
Before Aaron comments, so one of the things I'll just do some
Eat the mic. Eat the mic.
One of the things that you said, measuring everything. So when you have a generic routine that you could just like plug in a URL to test to, it's easy and tempting to like want to measure everything, right? To Robert's point. But man, I gotta tell you, when you do that and take it from me, because we got there at one point, the volume of data that you end up having to kind of sift through, it's not only is it distracting, but it almost becomes an impossibility, honestly. So like there is So there's some of the measurements that we ended up, that we're still doing. We ended up reconfiguring them to be very explicitly targeted towards like internal endpoints, so that we can kind of get back to the basics. But there is a kind of dangerous side effect to like this temptation of measuring everything. It's my pacemaker. Okay.
Right, Aaron.
So, in my day job, I've run into a bunch of stuff related to Anycast. I'm discovering that Anycast is a real pain in the ass to diagnose.
It's a technical term, right?
That's a technical term. It's a technical term I use rather frequently. I'm wondering is this something that you guys are seeing, thinking about? Is there a need for tools? Is Anycast like on your radar, or is it such a small amount of stuff that you don't care?
So talk a little bit about Anycast and that we use a lot of it. Yeah, I mean, I think getting tooling around how Anycast, because the traditional networking, you're not going to necessarily understand how an Anycast distribution works very well. Obviously you can test it from multiple points, et cetera. The other thing that's unique about Anycast, depending if it's inside a network, it behaves one way. When it behaves across networks, it behaves totally different again. So when you're doing, between networks, and that behavior has to do with, it's the political layer of how we route traffic. So things that you think were going to happen don't actually happen. And it's a fundamental thing that we grapple with every single day, and that we're one of those networks that have to go between networks. So what we did with it is not what the next provider will do with it, and it's a major issue. The other thing too is, without giving away the farm, people who run, interdomain Anycast networks do things to specifically try to circumvent certain behaviors, like you don't want to black hole traffic. So you don't distribute things you have very unique distribution patterns to make sure you get you're trying to block against black holing, but you also want to try to get performance. So you have to then understand not all things are equal. So if you have a provider that has, a number of Anycast blocks, doesn't mean you should expect to see the same thing from each one of them. The answer is you shouldn't expect to see the same thing. And if you did, well, then they might be in trouble if they have some weird issue on their data centers. So I think that's actually a very interesting question, but I think it may be different for inside an SP and across interdomains, because there's different behaviors you see. And that political layer issue is everyone's entitled to route traffic the way they want, and they sure as heck do it differently at times.
NSID is my friend. So the Anycast is we use it a lot. It's all of our DNS servers have Anycast addresses. And Aaron, it does add a level of complexity, to be honest with you. But I think the tools need to evolve. One of the things that I did over this past holiday is so some of the measurement stuff that we were talking about here, I updated a lot of that code to basically capture NSID information, right? So like when I'm working with folks that are at your day day job, right? I have sufficient level of information, but even with labels that come in the form of NSID, A, not available everywhere, and B, it still is only like maybe 1/2 of the equation to really triage and diagnose situations that are kind of cross domain that have an impact on customers. It's tough, and I think right now I'll say it's important, and what's the important part is making sure that we have the right tools to continue to go ahead and do that without me having to actually call you specifically, right? We need stuff that's available generically, right? Automatically.
So I just want to add one thing I forgot to mention earlier, and something that John said reminded me of it. The other thing about Anycast, I think John said something very important, which is get as much data as soon as you can. Because one of the things that changes as where you go change over time, there's one very large value that changes. Latency suddenly changes drastically on you, potentially, and that could be by design. And to understand, what the limits are, because suddenly something that looked close is far, but is that good, is that bad? So I think getting data and be able to measure and understand it over time and trend it over time is a very important thing. Because we've noticed when we test our own things over time, you get a lot of different. There's a lot of versions of good that you actually can get out of that data.
Line is getting longer, so I'm going to keep it short. From our perspective, from the measurement network point of view, Anycast versus Unicast is like V4 versus V6. We just do it, so it doesn't matter for us which one it is. That said, that's true for the most part, but some consequences we have to deal with. For example, we can, when you want to visualize stuff, then you cannot claim that it is in a single place. So, you know, your visualization tools have to have the knowledge that it might be that it's in multiple places at the same time, and it's okay. We've been doing DNS Anycast measurements since epoch, so you know, that kind of stuff is nothing on the measurement network level. It's nothing new. All the root DNS servers, basically all of the DNS servers that we measure, we do.
Right. Do you have a right FQDN, like, you know, anycasttest.atlas.ripe.net?
I think it's called k.rootservers.net. Yeah, that certainly just works.
Okay, Al?
Al Morton. I've got a broad view of network health, and I want to try to broaden it for everyone. It's hardest to keep track of when everything is green that we've been given to monitor our networks. So what that usually means is the problem, if it exists, is outside of our operator control. John touched on this with the DNS problem. Had to go and get some help from folks outside, right? And it's going to be the same thing with our new partners, the content distribution networks. They can change things very quickly, even during a session. And it's got very little to do with performance, let's say. It could just be about price. And it turns out there's lots of content distribution networks, not just our friend who I asked to stay close to the mic, Aaron. So I wonder if you guys have got any experience with sort of partnering with the CDNs, back up, partnering with the CDNs to do this troubleshooting when it occurs. And a quick note, I think we can get some help from instrumenting the media players. And there's many media players. There's all sorts of things that they could tell us about stalling, which is the most heinous thing that can happen apparently. And but we all put up with it. And there's actually some CTA work in the U.S. going on to try to instrument that and get that part of the piece shared with all of us. But so I'm wondering, let me just turn it over now to the panelists. What are you guys doing with CDNs?
I'm going to give the mic to John for an authoritative answer. But in the meantime, I did have an idea of a draft for NSID for HTTP. If anyone is interested, you know where to find me.
I call a coworker of Aaron's, Eric Nygren, who's probably not here. So that, I mean, you're right, man. I mean, it's a true statement, right? But like, and that's one of the things that I mean, a lot of the work that I've done over the personally over the past 10 plus years at Comcast. Not only have I built a great relationship, but a lot of those relationships turned out to be really great friends, right? People I hold in high regard, right? So like what ends up happening is I let my fingers do the walking, right? And when we see a problem, I pick up the phone and make a call. But that's my point about what I was saying. That I think that Aaron and I were going back and forth. That works great when you know somebody, right? But not everybody knows somebody, man. I mean, so like we have to come up with a way to make that more dynamic, more systematic, programmatic, right?
And some guys use many CDNs, not just some small guys out there right on their road. Absolutely.
Randy?
To rewind a bit to drowning in data. We measure our network a bit. I also have the measurements from some other networks. It's not the volume of the data that bothers me at all. We've got net flow from our 1,000 plus routers. We've got and I've got access to clusters with 50,000 cores. What's the missing is intuition. And that's what research is about. And we can drown in data and we can learn to swim. On your question about baseline latency performance across the network and changes in it, etc., I can show you another paper.
Thanks. Any follow-up comments? Nope. Okay.
Hi. I work for SIDN, it's the .NL TLD operator, and we are of course interested in Anycast and performance. That's what we do too. We have been doing a bunch of work in that DNS optimization. Got a bunch of papers out there, working with people from USC, ISI. But what I want to tag on Anycast is it like, let's say if you have Anycast has worked pretty well configured, you have even the political layer configured pretty well, but out of a sudden, if you're a DNS provider, you have a new client who has a different incoming traffic pattern from different regions, and so this new client has a different catchment and it gets poor performance. And if you share the same infrastructure, or at least part of it, if you try to optimize from the new client, what's going to happen, other clients going to be shifted around the different data centers, and they may suffer, so the problem just gets more complex. So what I'm trying to say, Anycast that's what I'm seeing. We were looking at the data we are seeing currently, it's way more complex than it typically is.
Yeah, and the other thing, depending on the size of your network and how you're, configured, you may have it set up the right way on your end, right? But you may have an intermediate network that makes that makes some decisions that end up having implications for you, right? And it kind of makes the argument for some of these, background active measurements that are always going out and like checking things. I mean, I think you're kind of reiterating some of what you talked about.
So you want to add first?
No, go ahead.
Yeah, and maybe Robert or John may or may not agree. The other thing too is there's what I mentioned earlier, which is you have things happen to other people's networks you can't control. But even down to the fundamental SP networks, their networks operate a lot of time differently. His decision, like egress and ingress in an SP network, typically is not aligned, right? It's asymmetric, and that's maybe there's some networks that are symmetric. Maybe you have one transit peer, and that is pretty easy. But especially you have a lot of peering, or you have a number of transit providers. How you decide where you want to send your traffic, typically based on some economic reason, doesn't match how it comes back to you because someone else decides for their economic reason they're going to send traffic in a different way, and so now you have two different static latency paths, right? And there's a paper maybe on some of that, but those change fundamentally, and those can change drastically. And they'll also the failure mode is different over time as well. So what transitory networks you may go through is not always constant. So it doesn't always go from A to B. It can go A to C, and that's a version of normal as well. So again, just to reiterate, I think Anycast provides an interesting nature which I'd like to see attacked.
Yeah, and I think just my point is like there's no one size fits all. If you try to optimize for one client, you might breed the bad things for others.
In addition to that, Anycast is hard. Everything is hard today. It's not necessarily true that if you add a new Anycast instance, then things will get better, right? So intuitively you would say, oh, now I'm going to be closer to more clients. In fact, yeah, maybe, but you're attracting traffic onto already saturated links because BGP doesn't really care about saturation of links and all that stuff. So, we had cases where we had to shoot down a K-root instance because it made things worse. And that's actually an interesting research area. If anyone's interested, I have lots of data. K-root is constantly expanding. All the other routes are constantly expanding. Is it all for the better? Every time we add the node, something changes. If there are DNS inclined people, talk to me.
There's a paper on PAN this year exactly on that. They compared two different routes to have different number of Anycast sites, and I think one has, I don't remember which one. The one who has fewer sites performs better than the other one.
And L route is in like 200 places now. I route is expanding, F route is expanding, K route, everyone is expanding, and we think it's for the better. But someone might actually double check that.
But there are two things. Like you can think of normal operations and what happens under a DDoS attack, right? It's just a different scenario.
Oh no, this is under normal conditions, right? So don't even talk about it.
Okay.
Hello. Josiah. I'm from the University of Cape Town in South Africa. And recently I also started working with Frenik. So I've got two questions, maybe just to give a bit of background to that. So my interest has been measuring internet performance in Africa mostly. And so working in a region where you don't have that many vantage points for measurements, sometimes you'd want to use various platforms. So I've used RipeRTrust, I've used Kaida, and recently also I've used Speed Checker. So one of the frustrations sometimes is when you're trying to merge these different data sets, you've got different formats and you've got to go a number of steps to try and bring these data sets together. So my question would be, any efforts, or do you think there is any importance to trying to come to a point where we've got sort of a standardized or a standard for the data formats that we can have from these different platforms in general?
I'm all for it, but I'm just moderating.
One slightly twisted answer to that is there is such a standard. It's on the wire. Okay. Right? That is the standard. Is that the best way to disseminate the data that you collected to users? That could be a different question. I personally was very optimistic when I first saw that LMAP started up, and there is going to be standardization in this space, and that's awesome. I don't think that the actual measurement results are standardized yet. Maybe there's more work to do yet there. What I can say from our perspective is that if there is a standard that says this is how you should disseminate your traceroute, your DNS, your ping results, I would be happy to provide translations from what we have to the standard thing. That's not a problem.
Yeah, so I think as much as it may be technically true about the wire, it's not practical though, right? Leslie and I have been talking about this for a while. I mean, I think the idea would be perfect if there was like a JSON template that says, hey, if you wish to publish your data and you want to self-publish, here's the format, send it here, right? And some organization will gladly digest it and help summarize it for you, right? I don't think we're there yet. I think maybe we should talk afterwards, but I think there's a number of us in this space that really think that would be useful. So it's one thing everything that I've done is a proprietary, super complex, comma delimited format file, right?
Yeah.
But it shouldn't stay that way, right? There should be a way for us to kind of generically represent these things so that you can pass it around to people. I mean, I like to be able to work with Aaron and say, hey, Aaron, man, do you want to feed some of this measurement data that you can subscribe to so that you can see what's going on, or even like LinkedIn or Facebook? I mean, that'd be pretty sweet, because right now every single consumer of that data has to now have their own parsing routine to figure out what does field number 12 mean, and what happens when John inserts a new field number 12. Then I can go back and retool all these things. That sucks, man, right?
Yeah, so I think it's two things. It's format in which to exchange it, but it also has to be a rational and limited number or type of measurements, right? Because the data doesn't mean anything if you don't know anything about how it was taken. So I think there's definitely...
Yeah, exactly. I was going to say, okay, apart from the results, you also want some standard in terms of metadata. For example, if I'm merging RIPE and Speed Checker, I want to know, okay, this measurement was run from an end user's device in a Wi-Fi network, etc. So that when I combine these, I know that these are oranges, these are apples, and so on. And also, in Africa, we are also having lots of internet users that are accessing the internet from mobile devices and so on. So one of the challenges also is trying to measure much more from those vantage points, from the end users' mobile devices. There are quite limited tools of distribution of vantage points in that space. I don't know if you've got ideas. We've tried to use some tools, Speed Checker, one of them. Very hard to get users to install the app on their phones because it uses data and so on. I don't know if people got ideas how we would get to the point where we've got more vantage points in the mobile space.
So to share some of back when I was, designing and architecting around the mobile network, one of the challenges from an internet perspective is most of the infrastructure is actually invisible to the internet in a mobile network. You pass right over it. The first point of access to the internet, as the 3GPP guys call it, the PDN gateway, is the RAN, where most of your latency likely is, and a lot of your rerouting will happen. and then into the mobile core. So, one of the challenges there is to get the mobile providers to help provide tooling on the substrate infrastructure that actually comprises most of what is the experience. Is once you get up to your first gateway, that the mobile network thinks that's just a link, right? But it's not. It's actually a complex, long, large network that typically has, especially in earlier infrastructures, probably a significant amount of aggregation. So there's a lot of backhauling. And then just to throw one more piece in there. So I think getting that substrate tooled is important. The other thing too is if any way to get some of the exchange, like the GPX, IPX exchanges to actually tool that part, because with roaming, unless you're doing local breakout, you're actually crossing back to your home network. So there's versions where understanding how that performs is relevant to what is an internet experience. If that makes sense.
Great, thanks.
And just to confirm, I fully agree also with the metadata argument, and we're trying to do our best to do that. Like, every piece of result that we deliver has like what kind of firmware did do that, and if that firmware had a bug, you can look it up and so on and so forth. As it has been pointed out before, we can always do better, but at least we try to do that as well.
Yeah, thank you very much.
So Brian, I think you'll be our last question.
Well, then I have to make it good. So make it brief. Actually, I think that the metadata conversation kind of went in the direction that I wanted to. I think all the questions that I have are answered. If I could make a comment. Go ahead. On that. Actually, I'm going to get up here and not abuse Robert. I'm going to praise one of the things that the Ripe Atlas guys have done. Yeah. In that, so there's a couple of dimensions here, right, on how you make data available. And one of the really nice things about Ripe Atlas is what's stored in the database is what came directly off the probe. So you have, not ground truth, but you don't have any problems where there's some sort of intermediate data munging thing that's going to mess something up in a way that you're not going to be able to debug ever. One of the really annoying things about Atlas is that the data that comes into the database is the stuff that's directly on the probe, right? So, there's trade-offs in the space that need to be made if you talk about interchange. And I think that, I think we know how to do a lot of these things with metadata and keep the metadata together with the data and make sure that we don't make gratuitous changes to the data as it's stored. We've learned how to do these things, and I think we keep not, in the IETF, we keep not solving that problem, right? I know I'm going to point to a draft that I haven't read, but I read I'm going to put Al on the spot here and point out that we're actually taking on the traceroute problem. People are trying to take on the traceroute problem again in IPPM, and we might actually take it on. That turns out to be really difficult. Formats, there are an infinite number of possible arbitrary choices that you can make in how to represent traceroute.
Hey, it's not who is.
Oh. And Leslie wins, and we're all done. Thank you. Huh? It's not infinite. It's just large. Yeah, it's. There's half a PhD in that statement, really. But actually, getting people who've worked on measurement, people who've worked in standards, and people who actually use routing information for debugging, especially some of the really interesting stuff that can happen with Anycast, together to kind of bang on that problem might be worth doing. And everyone who's nodding gets to help contribute to that effort. And I guess I have to do so as well because I said that it has to be done.
So one comment on that, and then I have one question for everybody, if that's okay, Leslie. So one of the things that we had to do as part of this measurement system that we augmented over this past holiday is we built a remote trace route.
Into the mic.
We wrote a remote trace route agent. We had to basically hack. Not that this is rocket science. We had to basically hack traceroute into a JSON format so that we knew what changed along the path, right? And we've been, we all have been hacking the hell out of traceroute and different ways to find it and manipulate it over the years. That's just the most recent incarnation. So I don't disagree with you. I'd love to, if you could send me a pointer, I think that'd be great. Happy to take a look at it, Al, or whomever.
Yeah.
That's fine.
First off, it's not just Al. It's joking.
Yeah.
Yeah, it doesn't matter. Whatever. You get the idea.
Great.
Great.
Okay. Yeah.
Super. Lovely. So,
yeah,
I'm happy to take a look at it. Whoever.
I think that's on the real agenda for IPPM. Yeah. So. Yep. So
okay.
Good. Yeah. So come to IPPM. You'll also get to miss the wonderful TLS 2804 discussion.
Okay.
Okay.
Cool. All right. Thanks.
Yep,
Thank you. And John, you have a question.
I do have one other question. So everything that I think we've all talked about here, I put into the category of an active measurement, something that we run some code, it does some things, brings back some data, right? So I'd like to understand, and I'm kind of new to this group A and R, W, right? One of the questions, and honestly, this is actually something I don't really have an answer to, so I'm looking to you guys for some advice and some guidance here. So lately there's been some discussions around people who say, you know what, you don't need to actively measure. Okay, so then what do you do, right? So like Robert said something about raw bits on the wire, right? So is there any work being done where people can say, hey, there's research in this space where somebody says all they do is look at interface counters and the time and increment by which they change, not an active measurement, but they're looking at like just raw data and making assertions about the raw data. So it's a step away from what I would call kind of a bona fide user experience, right? Like there is no user. We're just looking at byte counters on the wire for a protocol and doing just simple delta math between different points in time. And there's some assertions that are being made that I don't know if I entirely agree with, that like you can do the same thing that way as an active measurement would do. And I struggle with that a little bit, right? So I like to get either a reaction or, hey, is there like a research paper that you can point to so I can get smarter on those things?
I think you can rewind to Vern Paxson's master's work and go forward through a whole lot of stuff. Path char from Van. Brian, you have a better memory than I do. Come on. There's tons of stuff on passive measurement to get performance on the wire and infer other performance. What Vern was doing after that, vital signs where end users had, go ahead, Hal's smarter on this stuff than I am.
I just want to get behind you, sir.
But Vern had a thing that ran on the end user's laptop, which used passive measurement to tell the end user, was the problem here, was the problem on the wire, was the problem the server. Okay, there's a long history of passive measurement.
So the easiest citation I can give you, John, is the Passive and Active Measurement Conference, which has been running, I think, since 2002. And note the order that they put that in. It's not the active passive measurement conference, it's passive active. So there's tons of good stuff in their papers over the years. But the thing that put the kibosh on that is kind of the Snowden revelations. When we were doing the large scale measurement of active, of access performance, LMAP. Everybody said, oh yeah, we're not going to be able to do this passive stuff anymore. Nobody wants their stuff touched. And we can't even talk about it. So, I mean, there's got to be some balance here. And obviously the encrypt everything all the time guys are going to blind us to passive.
Yeah, so I was going to say we're actually that question opens an entirely different workshop that apparently will take place here starting at 5 p.m. But there's no, I mean, yeah, yeah, no, it'll start upstairs at 5 p.m. I would let's actually go have a beer and talk about this. There's like also every paper Mark Allman, well, half the papers Mark Allman wrote in the mid-90s talking about doing TCP inference. And this is actually one of the big discussions that we're having with QuickWhite right now. Is there are a lot of there are people who build boxes that will give you this information off of TCP. I think Thousand Eyes actually does this that Randy mentioned. And when you sometimes they do it wrong, right? So this you're saying you're a little bit skeptical. It's like if you do the really stupid thing looking at sequence numbers and acknowledgement numbers, you're going to get a bad data stream. It's going to give you a bad estimate of what the loss. And if you are a little bit smarter about that and you're willing to make deeper and deeper inferences about what the endpoints are doing, then you can get better data off of that. And we're actually looking at some work on how we can design that in to Quick in such a way that you won't have to do too much inference to make it work.
Yeah.
So I like that mention of beer. So
Yeah,
with that, I think it is time.
Because I
last comment. I guess I've just been too lazy, and active seemed like like it was a lower hanging fruit. But I appreciate all the feedback. Thank you.
Yeah. So let's.
All right. Thank you to the panelists. Thank you for your attention.
So quick final word to close this. Yeah, thanks to all of you for attending. Special thanks to Matt for his support on running things in the background, making badges and so forth happen, and the generous support from ISOC. To our other sponsors whom you can meet upstairs again. And also to Stephanie from the IRTF team, who has been doing a tremendous job in getting us organized, sometimes on short notice, less than 24 hours, and yada, yada, yada. So she has been doing an awesome job. So looking forward to see you upstairs at the Cloud9 bar for beer and some more food. And more beer. Thank you.
Give me 1 minute. I have to use the restroom. I'm going to explode.